Hey, everybody. Welcome. We're here to talk here for a few minutes about something that we found really fun, definitely very nerdy, and that is how to what we call time travel your data, which is something that we did with Splunk as part of our Boss of Ops and Observability program. So, first, I want to introduce a couple of people. The star of our show here.
Hey, I'm Robert Gustafson. I'm a sales engineer here at Splunk, and I specialize in getting data out of the cloud and finding value in your cloud data.
And my name's John LeBaugh. I'm the originator of the Boss of Ops and Observability program that we have here. I've run this program for about 5 years at Splunk. We've had a lot of fun iterating in this and building this. I'm going to tell you a little bit about what this program is, and then we're just going to dive right down into a little bit of behind the scenes on what we're doing and how we're doing that. And you can really kind of enjoy nerding out with us a little bit on our AWS experience doing, let's say, time travel with data, right? So, first off, foremost, what is Boss of Ops and Observability? This program is a way that we reach out to our customers and let them experience for free um, all of our observability portfolio and products. And we do that by creating a whole bunch of data and allowing you to use that as you would in your day to day lives in a little bit of a competitive, fun, challenging competition that we've put together. So it's about 4 hours that you spend with us where you're going to be challenged to answer a series of questions, see if you can win the competition by answering those questions fastest and most correctly amongst your teams and peers. So we do that by putting together a number of what we call episodes. In this year's version 5, we have about 12 of those. Those 12 episodes are uh, across a variety of different data sets from our iRacing partnership data with McLaren. And if you've seen the data drivers program, there's some of that, all the way down to like Microsoft O365, as well as AWS data, and even a little bit of just fun data that doesn't necessarily make any sense, but it's a lot of fun to play with. We preface this by saying, hey, you're going to work at our famous Splunk t-shirt company store. So you're going to role play as Ace, who's the man of the hour or woman of the hour, if you want, to solve all of the problems. They are the go-to person, and of course, that is you. You're going to use the Splunk observability portfolio to solve all of the problems and be the hero of the day. The problem is we needed all this data to show up and work with you in a realistic, real-time fashion. So this is where Robert comes in and saves the day for us. Taking all of this data, saving Brittany, freeing Brittany, and putting all this data into a real-time, real fashion, uh,
Real world
real
scenarios.
world scenario that happens in real time. A lot of reals there. So this is the problem, right? So real time data, real time outages, just like things happen in your day to day, your real world, they have to happen as you play the game. But when we're playing the game, we need to know what's going to happen so that we know the answers that are happening in the future. So this presents a significant challenge as far as doing this. And here's how we solve that problem.
Yeah, so what we do is when we have a new episode we want to create, a new scenario we want the gamers to play, we go out and we actually have that scenario happen in one of our environments. So we go out and we record a known data set. So maybe there's an outage in the cloud. So we actually go out, we cause that outage, we collect all of that data in Splunk, and we go through and we say, oh, okay, here's the events that we know are important to the gamer that we're going to want them to find. And that might have happened back in June, July, August. But if you're a gamer playing this game, you're going to be playing maybe next week on December 8th. And we want that data to look like it's playing out for you in real time, not that it happened way back in August. So we run a couple of Python scripts, write a couple of regexes, do a lot of finding and replacing on those timestamps. And now we're able to present that data to you as if it's coming out in real time. But as you can imagine, that's a lot of compute. And this process can be very laborious if you have huge Splunk data sets like most of our customers do. And so the way we approached the problem historically was we tried to multi-thread out the finding and replacing process. We spun up some huge EC2s to do that with a lot of cores. But even at spending as much money as we can on EC2s, the amount of cores that we were able to purchase still got this process down to about 3 hours, which was really slow. And as you can imagine, maybe you get 2 hours through that process, you find an error, you got to start all the way back from the beginning. And it just becomes not only expensive from a dollar standpoint, but also from my sanity as well.
Yes.
So we were trying to think about, this seems impossible. How can we make it faster? Well, we were able to figure it out and make it possible. And we did that using AWS technology. So one day over the pandemic, I went to my whiteboard at home and I sketched out how can we take this from being on one server to being a serverless solution. A couple of things we can talk about here. I'm happy to talk about this with you guys further in detail. Is we moved all of our data sets from the local Splunk servers into S3. Once they were in S3, we broke down the find and replace problem that we had into really small chunks, and we put those chunks in the Lambda functions. So now what we're able to do is take each of the data sets from one place, from one server instead of many, and process them almost with infinite scale using Lambda. So instead of maybe running 64, 128 processes simultaneously, we're able to run thousands. And then once
tens
the
of
data
thousands.
is tens of thousands, once the data is then processed by Lambda, it gets stored back in S3 in a proprietary Splunk format we call Smart Store. So now hundreds of Splunk servers can all access that data simultaneously and without any latency. And so what was the actual result? Did this actually work? So now we have a single execution of this process. We don't have to run it across multiple EC2s. Most importantly, though, we're able to reduce the time that this actually takes from 3 to 4 hours on a giant EC2 to just about 10 minutes, and we only have to run it once per event. So the cost reduction here, it was costing us a lot to run all those EC2s for every event, but now we're down to $6 per event, which is really awesome. And our development time has gone down, and our sanity has been regained.
Yes. Multiple CLI commands down to one push of a button. It's fantastic.
Yep, it's pretty awesome to watch. So, of course, at Splunk, we wanted to look at our own logs and see how we were performing and kind of get some insights from that as well. So every time this process runs, it generates a ton of CloudWatch data from our Lambdas. And we brought all of that into Splunk so we can analyze the actual process. So here on this dashboard, you'll see over the top left, how many Lambdas are actually executed per run. So that's about 12,000 that we have running. That takes about 10 minutes to process about 20 gigabytes of data. And we know from the CloudWatch logs how long each Lambda is executing, and we're able to convert that runtime into a cost. And so we know that each time we run this, it's costing us about $6. But now where things get even more interesting is with a couple well-placed log statements with timestamps in our Lambda function, we're able to actually see how much time and money each one of the processes within the Lambda function is taking. So for example, this big red box down here, that's the actual finding and replacing of the data. And that's taking about 85% of our time and costing us about $5. So we know that this is the biggest chunk. Maybe there's some optimization we can make there to actually further reduce our costs. One place that we were able to reduce is in some of the other chunks on here, which is moving data from S3 and back to S3. We were originally doing that uncompressed, and it was taking longer to move. But once we realized that that was a point where we were spending money, we learned, okay, well, maybe if we compress it, the data transfer will be a little bit faster, and then we can do the decompression or uncompression on the Lambda, and we actually saved a bunch of money there too. And then the last chunk on there is just some Splunk proprietary processes that we can't really speed up, so we know that we can avoid that, having optimized that box. So that was really cool. So not only were we able to know exactly how much it was costing, but how much each process was costing, and then where we could make optimizations to even save money further and make it faster. And then finally, of course, we have error logs. So anytime we run this, we want to make sure that our customers are playing the game and that they have the full data set available. So any errors that might pop up show up in here as well. Luckily, the errors that we found today were just
were my fault.
Some old data files that John had left in there. So it's actually kind of cool that Splunk can let me poke John in the eye once in a while. So that's always fun too. And that's it. I'll give it back to John.
Oh yeah, thank you very much. Very cool stuff. I mean, this is one of my favorite parts of doing the Boss of Ops observability. The behind the scenes stuff is just getting to nerd out with this stuff and figure out new solutions. And the king of figuring out solutions is Robert, of course. So with that said, we want to make sure that you get an opportunity to join us every time that we play this game. We actually do have one coming up on December 8th, Wednesday of next week. It is free, available to all. You can, if you feel like joining us, bring 3 or 4 of your friends, put together a team, come play. You can either scan this QR code or just go to boo.splunk.com, log in and register, and we would love to see you there. All of this stuff that we've done, you've got a little bit of a sneak peek of how that works. We want to make sure that you get an actual chance to join us and have fun with it. So it is a great, fun time. You will definitely come away having learned something, whether it be about Splunk or even about just new data sets that you may want to explore within your environment using whatever you may choose to do. So we hope to see you there. Really appreciate your time today. Thank you.
All right, thanks.
Hello, and welcome to Boss of Ops and Observability, or, if you're pressed for time and into the whole brevity thing, boo. You might be wondering, why is Shelly here? Well, because I'm a big deal, and so is this. The Splunk t-shirt company needs your help. We have a problem, some sort of technology situation. I'm old school, Tori's busy, and Frank, well, Frank doesn't really do anything. So we're relying on you.
Thanks, Shelly. Once you've shaken the Vegas off and you're back home, join Splunk for Boss of Ops and Observability, or as we lovingly refer to it as BOO, on Wednesday, December 8th at 10 a.m. U.S. Pacific Time. BOO is a gamified capture the flag-esque competition where participants leverage Splunk's observability and IT capabilities to answer a variety of questions related to real-world IT and DevOps incidents. So get your team together. Get ready to claim your title as Splunk's Boss of Ops and Observability on December 8th at 10 a.m. Eastern. Register now at boo.com or register via the link below.
Good luck, and thank you.